Welcome. Today we look at permutations and combinations. So with permutations and combinations, basically the difference is on the ordering. In permutations, the order is important, and in combinations, the order is not. So as long as an arrangement has the same terms, even if the order is different, it's considered the same under permutation. Here is what I mean. Suppose we have three letters A, B, and C, and you're asked to arrange them 2 by 2. The possible outcomes then would be you can arrange it A and B, or it can be A and C, or you can start with a B, then choose letter A, or you can start with a B, then choose letter C, or you can have C, then A, then C, then B. These are all the possible outcomes of you arranging these three letters in twos. So with permutation, AB and BA, though they have the same terms of A and B just arranged differently, they are considered different. Same with AC and CA and BC and CB. These are all different from each other under permutation. Therefore, from these, we would say we have 6 permutations. However, with combinations, AB and BA are the same. The order is not important. The terms are the same. So AB and BA are the same. So we'll count this as one outcome. The same as AC and CA. These are also the same. So AC and CA are also counted as one outcome. BC and CB are the same under combinations, so BC and CB are also counted as one outcome. Therefore, for these three letters arranged in 2, would say we have 3 combinations. And that's how these two differ. So there are formulas that you can use to find permutations and combinations, because you can't afford to always have to arrange the possible outcomes. Sometimes they could be tedious because of the many possible outcomes that there is. So today we'll focus our study on permutations. Just have just the basics on permutations. So we have these letters arranged in twos, and we have 6 permutations. So how do we get the same answer using the formula? So the formula that you use for permutation is P n r is equal to n factorial over n minus r factorial. Sometimes r is replaced by k, doesn't matter, still the same principle. So with the notations, we have this one. Sometimes it's also written as P r like that, or P and an r down there. So you have these notations simply meaning permutations. So you have n terms and you're choosing r terms at a time, or choosing k terms at a time. But then we also have this factorial introduced. What is n factorial? So n factorial is just simply the product of all the integers starting from n, the positive integers from n all the way to 0. For example, if I have 3 factorial, then 3 factorial is 3 times 2 times 1 times 0 factorial, and 4 factorial is 4 times 2 times 3 times 2 times 1 times 0 factorial. 0 factorial, on the other hand, was agreed that it's equal to 1. Therefore, in most times, you always end at 1, because 0 factorial is just a 1. So, trying to use the formula to find the permutations that you can get from 3 letters arranged in twos. You're going to have P is equal to our N. The terms that we have here are 3, and we're arranging them in twos, so R is 2, which is equal to 3 factorial over 3 minus 2 factorial, and this is 3 times 2 times 1 over 3 minus 2 is 1, and 1 factorial is just 1. This is equal to 3 times 2 times 1 is 6. Permutations are 6, the same as what you found when arranging. So this is how you use the formula. Let's have an example. Suppose we have 5 people, A, B, C, D, and E, and wish to make portraits of only 3 of them at a time. So how many such distinct portraits are possible? Distinct order is important, because we start with the tall guy, assuming they are tall and short people. The one that you start with the short person is different, it's distinct, it's different. So then we have P, our N is 5, and our R is 3 at a go, which is equal to N factorial. Our N is 5 over 5 minus 3 factorial. This is equal to 5 factorial is 5 times 4 times 3 times 2 times 1 over 5 minus 3 is 2 factorial, and this is equal to 5 times 4 times 3 times 2 over 2 factorial is 2. So 2 in there, 1, and that other 2 give us 1. And this will give us 5 times 2 is 20. 20 times 3 is 160. So we have 60 such distinct portraits if we are going to select 3 people at a time from a group of 5 people. An alternative for this division here, because 2 factorial is a possibility here, so you can always end your expansion to what you have in the denominator. What I mean is you have 5 times 4 times 3 times 2 factorial over 2 factorial, so that you can straight away just erase that to still give you 160. Our second example is a bit different. So we're going to have, suppose we wish to arrange 5 people, A, B, C, D, and E, standing side by side for a portrait. How many such distinct portraits are possible? So 5 people standing side by side. It means we want to have all the 5 people in the photo. With example 1, from the 5, we only wanted 3 people in a photo. So you may think of it like this: 1, 2, 3, 4, 5. You have 5 people to put. So before I get anyone to stand here, I would have had 5 people to choose from so that they can fill up this first place. After this one stands here, then I have 4 left to choose from. Then I have 3, then there is 2, then finally I only have 1 person to fill up the last place. So by the fundamental principle of counting, the total number of outcomes that can come, distinct outcomes that can come from arranging 5 people side by side, is simply the product of these possibilities: 5 times 4 times 3 times 2 and times 1, which is equal to 5 times 4, which is 20, and 3 times 2 is 6. So 20 times 6 is equal to, we have 0, 2 times 6 is 12, so we have 120. If we're going to use the formula, we're going to have P5, sorry, going to have P5 and we're choosing all the 5. It's equal to n factorial is 5 factorial over 5 minus 5 factorial, which is equal to 5 factorial over 5 minus 5 is 0 factorial, and 0 factorial is simply 1. So what we have is 5 factorial in the end, and 5 factorial is 5 times 4 times 3 times 2 times 1, which will give us 120. Which is why whenever you are choosing or you're arranging all the people that you've been given, or all the items or objects that you've been given in the question to arrange, they say the permutation is simply n factorial, because even if you have it down there, it will give you a 1, which is the n minus the n. You're choosing n from the n people to arrange in that distinct order. Thank you.